Hi, I'm Randall Hayman, a university academic, and you're on one of my Corona Help playlists, where I do quick turnaround videos to help educators and students during the coronavirus outbreak. If you'd like me to make a video for you, then just comment below any of my videos or drop me an email. And if I think I can help you and I've got the time, I will. Okay, someone's asked me, is 10Z or Z an ideal of the ring 5Z? Actually, the person's from the US, so I'll try and remember to say Z. Okay. Okay. So what they sent me is actually correct in concept. I've got no problems. They understand it. I just want to encourage them to write a little bit more mathematically. I think that'll pay off in a number of ways. So, okay, so what does that mean? So I'm going to answer this now in the way I would answer it. I'm not going to prove anything. I'm just going to, well, actually, maybe I will prove some stuff as we go through. And it's based on the 4 criteria that I talked about in one of my videos about ideals. So if you're unsure about that, search back through. There's a number of videos in this playlist on ideals. Okay, so how would we answer this? Firstly, the multiples of 10 are a subset of the multiples of 5. Next. So I hope that's clear. I don't know that I need to really prove that, but if you want me to prove any of that I miss, anything I don't prove that you want me to prove, just comment me or send me an email. Next, we require that the subset is empty, and normally for something reasonably easy like this, you can just say 10Z is non-empty. Of course, if you want, you could combine these two. Just say, you could combine the first two by just saying 10Z is a non-empty subset of 5Z. If you want to do that, that's fine. Also, so now here we've got to show that it's closed, 10Z is closed under subtraction. And here it's probably worth doing a proof. Suppose A and B are elements of 10Z, then A equals 10S, B equals 10T for some ST that are integers, and then A minus B equals 10S minus 10T, take out the common factor 10, so equals 10S minus T. So, and that here you can see that what we're saying is that A minus B is a multiple of 10. Oh, so I might actually write that actually, is a multiple of 10. So A minus B is an element of 10Z. And finally, we have to show this sort of closure. When we take an element of the ideal, multiply it by an element of the ring, we must get back to the ideal. So what's that saying? The ideal is closed under multiplication by an element of the ring, something like that. Suppose, let's call it, I can use A again, there's no problems with that. A is an element of 10Z, B is an element of 5Z, then A equals 10S, B equals 10T plus 5 for some ST that are integers, then A times B equals B times A, which is equal to, so this is an S here. So what's that equal to? 10S times 10T plus 5, and that is equal to 100T plus 50, and so that's equal to, which is equal to 10 times 10t plus 5, 100t, actually that's not right, sorry, that's not right, let's go back here. It's all right except for this little bit here. So this is 100, I better put st plus 50s, and that is equal to, I can take 10 out, that's the important point, it's 10 times an integer, and the integer is st plus 5s. So a times b is a multiple of 10. And this means what does that mean? That means this means 10z is closed under multiplication by 5z. That's one way of putting it, I suppose. And so, therefore, 10z is an ideal of 5z. So the person who sent it to me, if you don't need all the proofs that I've put here and here, doesn't matter. You can just make the statements that you need. Make the statement. So what I'm saying is, you could just go, firstly, 10z is a non-empty subset of 5z. Next, 10z is closed under subtraction. And finally, 10z is closed under multiplication with 5z. So that's how you would explain as succinctly as possible why 10z is an ideal of 5z. I hope that's helped. If you've got any questions, just let me know. Otherwise, any area of mathematics, feel free to comment me or drop me an email if you've got problems.